Conformation of ethane. Ethane is one of the example to know about the conformation isomerism of ethane. We will learn ethane, methane, ethane, propane, butane. We will learn three example of conformation isomerism. First of all, we will learn about the ethane. In ethane, we can simply write ethane. Ethane means this is the formula. CC 2 carbon means ethane. There is a HH bond. This is a 1 carbon, this is a 2 carbon. So the Neumann position formula of this ethane will be this is a Sahos position formula I have shown, but we first of all we will learn about the Neumann position formula for the learning that this is a Neumann position formula. This is a first carbon, second carbon. First carbon 3H bond, second carbon has 3 CH bonds, and this is in the back. After 60 degree rotation, the compounds we are getting this. See, this H will rotate to. Now this is a front carbon is keeping the fixed stationary, and back carbon is rotating. This back carbon after the rotation CH comes to this positions. Maybe we can anyone we can rotate. Front carbon maybe rotate in the you can rotate back carbon. Any carbon we can rotate and see what will be the result. If after the 60 rotations front carbon is keeping the stationary, backward carbon is rotating, this compound we are getting. After the 60 rotation we are getting the same compound, which is the this compound. As there is a H bond, all are the CH bond. If any other group will be there, if in the H positions suppose CH3 will be there, if in the H position CH3 will be there, then maybe there is a possibility of another conformation may be there after the rotation again with 60 degree. But here all are H bonds, that's why after the again if you rotate 60 degree, then the same compound we will getting this. This is in the fully eclipsed conformation. CH are in the back to back, all are H bonds, so this is the fully eclipsed. This is in a fully eclipsed conformations. Now if you will be CH3, maybe there is a partially eclipsed conformation possible, but there is not CH3 any other groups, only HS groups. So this is a fully eclipsed, this is a Astragar. So we did not need to bother about to say fully eclipsed, partially eclipsed, because this is only eclipsed conformation in the ethane is a in ethane. So this is a eclipse, this is a Astragar conformation, and the other than the Astragar and eclipse are the Gauss conformation and SK conformation I have shown, but only need to take care about this two conformation I have shown only for the, this is only for the knowledge purpose. This is a two conformation only possible. If we rotate again, then this compound we are getting. So this compound is getting, this is Astragar, from eclipse to Astragar we are getting after the 60 rotations. Now there is a Sahos position formula is shown. Here it is in the Sahos position formula. This is keeping the same. This carbon is rotating. After rotating, this form is getting. Similarly, if you from Neumann position formula, we can also draw the Sahos position formula. But most of the book only Neumann position formula is explained. So this is a new Sahos position formula. We did not need to much bother about the Sahos position formula. Now relative stability we are getting. Now this is a relative stability diagram. This is a potential energy diagram. This is a relative stability diagram. I have already shown that there is a eclipse conformations. There is a CH bonds are back to back. Eclipse are the less stable because there is a angular strain, torsional strain is there, van der Waals strain little bit there. Maybe we cannot neglect about the torsional van der Waals strains, steric strains, but angular strain is there. Torsional strain is there because CH one CH torsional angle, the angle torsional strain is there, van der angular strain is there, torsional strain is there. That's why there is a repulsion. There is energy between one CH bonds is 4 kilojoule. So 3 bonds are there. So that's why there is a 12 kilojoules energy is there. There is a repulsion and 12 kilojoule energy is here. Some books mention 12 kilojoule. Some books mention 12.5 kilojoules. But most standard is 12.5 kilojoule. This energy diagram is drawn. This is eclipse conformation. After the 60 rotation, we are getting the Astragar conformation. Astragar conformation, there is a distance between these two groups. That's why there is a minimum energy, minimum repulsions. So this is the most stable. Energy less, stability more. So after this eclipse conformations, This is the converted to a Steger conformation after 60 rotation. Again, after 60 rotation, this Steger converted to the eclipse conformation. After 60 rotation, this eclipse conformation converted to the Steger conformation. Only 60-degree rotation is there. So this is a eclipse conformation is a more stable because there is a less energy. This eclipse conformation is less stable. This Steger is more stable because there is a angle difference between these two bonds is 60 degrees. So there is a more distance. As the distance increases, repulsion decreases. Repulsion decreases, stability increases, energy decreases. So these two are the less stable because this is in a eclipse conformations. Less stable than the Steger. This is a Steger. Steger are the most stable. So this is an potential energy is shown 12.5, maybe 12 kilojoule. Some compounds, some books is shown 12 kilojoules. One CH bonds energy is 4 kilojoule. I have already explained. So this is a diagonal angle in this x-axis. This is in a x-axis. This is in a y-axis. Y-axis potential energy is shown, and x-axis diagonal angle is shown. This is the diagonal angle 60, 60, 120, 180 degree. The another diagram maybe in this way you can clearly say that this is an eclipse, this is an Steger, the eclipse, Steger, eclipse, Steger and eclipse. 60 degree, all the compounds have 60 degree angle difference. This is a less stable, this is a more stable, this is a less stable. This is a Steger conformations. Degree of rotation is shown, maybe diagonal angle. This is a potential energy. In this way we can draw ethane conformation. Here I have mentioned eclipse conformation is less stable. Why the eclipse conformation are less stable? Eclipse conformation is less stable because the hydrogens and bonding pair of electrons of on adjacent carbon atoms are near one another as possible. As there is a in eclipse conformation, two bonds are back to back. There is a higher repulsion. Higher repulsion, less stability. Less stability means higher energy. So that's why it is shown in the upper, because this is increases, energy increases. So this compound have higher energy. The eclipse form is thus less evident, means less found. As the stability increases, the possibility of finding a compound increases, but the stability decreases, possibility of finding compound decreases. This causes maximum repulsions. In the eclipse conformation, bonds are back to back, that's why there is a maximum repulsion. In the Steger conformation is the most stable, because this causes the minimum repulsions. There is a repulsions minimum, and this is found abundant, means they are found in more. If compounds is there, suppose compounds is there, then more part will be in the Steger conformation and less part will be in the eclipse conformation. Means if any compounds is given, then 80% of this compound will be in the Steger conformation, only 20% compound will be in the eclipse conformation. Why? Steger are the more stable, that's why the possibility of finding of compound increases. That's why this is written this form is most abundant, means they are found in major amount. Major amount will be in the, if anywhere compound is given, suppose this compound is given and mixed with eclipse and Steger, then the major compound will be Steger. Other important point, the other conformation lie between these two in instability. If not impossible to isolate the different conformation of ethane because they are constantly interchanging. Means two compounds Steger and eclipse are shown, they are not really can be separated because they are interchanging, they are changing from one form to another form. In a higher alkane, one or more hydrogen atoms of ethane are replaced by alkyl group, other higher hydrocarbon are substituted, then all that exists in this conformation. The study of this property is known as conformational analysis. Now we learn about the conformation of propane.